Chapter 3, Section 2, moving on to the Adept level, finding missing sides and angles. So in this box here with the quotes, this is just to refresh our memories on how to set up the ratios and which side goes with which one. So it's SOHCAHTOA, SOHCAHTOA, sine, cos, tan. All right, so in this example here, it's theta that we want to find. So we're trying to find the missing angle, and we were given two sides instead, so we have to choose which ratio to use, and I think we can do that pretty easily. 6.8, that is the opposite, okay, from theta, and the 11.1, okay, that's the longest side, that is the hypotenuse. So opposite and hypotenuse, that's the sine ratio, O and H, opposite and hypotenuse. So let's set it up. The sine of theta is opposite divided by hypotenuse. All right? So just like tan, all I have to do is use the inverse. And there's an inverse option. Whoops. Getting ahead of myself here. Theta, that's the angle we're looking for. That is the inverse sine as opposed to inverse tangent. It's inverse sine of whatever this ratio works out to be. Okay, you can work this out as a decimal, just be careful with your rounding. Okay, so let's quickly work that out on my calculator. Inverse sine, and I get approximately 37.8. This is an angle, so we're going to put degrees. All right, so that's our angle theta. Let's do another example. I have a rather skinny triangle. This is theta right in here. It looks pretty small. And the hypotenuse is 12.4 and the adjacent is 12.3. Because remember, the opposite would be right here, but it's not given and we don't need it. So which ratio uses adjacent and hypotenuse? Well, that would be the cosine. So cos of theta is the adjacent divided by the hypotenuse. Okay. Now, if you're working with sine and cos, if you get these numbers in the wrong order and you try and find theta, your calculator is going to give you an error. If that happens, well, 9 times out of 10, it's just because you put the numbers in the wrong order. Please don't do that. So theta is the inverse cosine of whatever this number works out to be. It's probably a disgusting decimal. Let's see here. So, and inverse cos. Now I should get a relatively small number, and I do. It's about 7.3 degrees. There's angle theta. Let's do a couple more. Here's my theta. That's what I'm trying to solve for. The opposite is given, and the hypotenuse is given. Opposite, hypotenuse, I use sine. So I'll set it up. The sine of theta is 9.7 divided by 11.8. Make sure you get the numbers in the right order. Therefore, the angle itself has to be the inverse sine of whatever this ratio is. So take my calculator and 9. And I get approximately 55.3 degrees. Okay. Now, the question doesn't ask, but what if we wanted to find this angle now? You have a couple of different options. Because we know that this angle is 55.3, we can take 180 degrees, subtract these two, and whatever's left over would give us this angle. That's one option. Or you could use trigonometry in that this 9.7 for this angle, that is the adjacent, and this is still the hypotenuse. So you could actually use the cosine, or inverse cos, to find this, and you would get the same answer. Here's our theta. The opposite is not given. We don't want it. The adjacent is given. It's 9.4. And here's the hypotenuse. It's 10. So this requires cosine. So cosine of theta is adjacent divided by hypotenuse. So therefore, theta is the inverse cos of this. And you could actually write this as a decimal because dividing by 10, that's a perfectly sound number. You would get 0.94. Okay, same thing. So let's ask our calculator, what is the inverse cosine of 0.94? And I get 19.9 roughly degrees. Okay. Pretty simple. So just to summarize with all this stuff regarding sine and cosine, treat it just like tangent. The only difference is we're not using the opposite and the adjacent. We're using the opposite and the hypotenuse, or the adjacent and the hypotenuse. How do you tell? Again, if you can memorize SOHCAHTOA, okay, it tells you which sides go with which ratio. I hope that's clear to you.